Hello everyone. Today I am going to discuss abnormal molar masses, Van 't Hoff factor and related numericals. So in our previous classes we discussed about colligative properties. No? So we discussed about relative lowering of vapor pressure, uh, then elevation of boiling point, depression of freezing point, osmotic pressure. So these, and we know that colligative properties depend on the number of the moles of the solid, not on their nature. So we know that when we dissolve 1 mole of a sucrose and 1 mole of urea, the lowering of vapor pressure will be same. Okay, because urea and sucrose does not undergo any association or dissociation in the solvent molecule. Okay, now in case of some solutes, when we dissolve them in a particular solvent, they may undergo some association or dissociation, and due to association and dissociation, the are molar masses of that particular solute is either less or more than our expected value. Okay, so abnormal molar masses is associated due to the association of or dissociation of the solute particles. Okay, so first association. First association discuss करें हमने. So association of molecule leads to decrease in number of particles. So if we dissolve a solute and it undergoes dissociation, suppose it undergoes dimerization. Dimerization means two molecules combine to give one dimer. Okay, so if association takes place, then number of particles decrease होगा. So number of particles যদি decrease হয়, obviously colligative property উপৰত effect পৰিব, because colligative property related to number of particles. Again we know, so colligative property is inversely related to molecular masses. No? So colligative property, relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, जोते हमें पाइसु molar mass of the solute की denominator side होता है. So colligative property inversely proportional to molar masses. So if the molecule undergoes any association, then the observed or experimentally, when we dissolve the solute in that particular solvent, molar masses obtained are higher than the normal molecular masses. Okay, so at an example consider, let us consider acetic acid. Na? So when we dissolve acetic acid in benzene, so acetic acid is the solute, benzene is the solvent. So acetic acid in benzene undergoes dimerization. So as you can see from here that this is the hydrogen bonding. So two molecules of acetic acid associated and they bonded through this hydrogen bonding, and dimerization takes place. দুটা acetic acid molecule combine হয়ে dimer formation হব. So experimentally or in solution, the molar mass of acetic acid exactly double হয়ে যাব. Acetic acid or ethanoic acid. So acetic acid or ethanoic acid or molar mass যিমান হব in solution, as দুটা molecule dimer formation হব, তার molecular mass to কি হয়ে যাব in solution double হয়ে যাব. So expected value যিমান তাতকে double হব due to dimerization. So molar mass যদি increase হয়ে যায়, so it will affect the colligative property values. Okay, and 2 moles now converted to 1 dimer formation. Similarly, benzoic acid in benzene undergoes dimerization. So number of particle decreases, molar mass increases. So abnormal molar mass is due to the association of this molecule. Okay, so association of molecule takes place due to this hydrogen bonding. So hydrogen bonding or karone duta acetic acid molecule associate with single molecular nisina lagise no. So molecular mass increase hoy gol. So this is due to association. Next, due to dissociation hole ki hobo? Suppose we dissolve some electrolyte. Suppose sodium chloride or potassium chloride. If we dissolve, then sodium chloride or potassium chloride ki hobo? KCl, K plus Cl minus hobo. K plus Cl minus when we dissolve potassium chloride in water. Now dissociation leads to increase in number of molecules. You see, KCl when dissolved in water, I may keep on K plus Cl minus. So number of solute particle increases. This is 1 in solution, 2 particles K plus and Cl minus. So number of solute particle increases, resulting in increasing in the value of colligative properties. So when we dissolve an electrolyte in water, suppose, then number of particle increases. So number of particle increases means colligative property value increases. Okay, again colligative property value is inversely related to molar masses. Therefore, molar mass of such substances as calculated from colligative property value will be less than its normal value. Okay, normal value আমি consider কৰিছো KCl, but when we calculate it exists as K plus Cl minus. So molar mass will change. Okay, so this is due to dissociation. So due to association, number of particles decreases. Due to dissociation, number of particles increases. And number of particles directly related to colligative properties. Okay, so this abnormal molar masses observed is due to association and dissociation of the solute particles in a particular solvent. যদি solventত solute molecule to association hoy or dissociation hoy, then we will get some abnormal molecular mass. Okay, so to account for this association and dissociation, Van 't Hoff introduced a factor I, which is known as Van 't Hoff factor. Association and dissociation karone Van 't Hoff introduce korle Van 't Hoff factor. And what is Van 't Hoff factor? So Van 't Hoff factor is defined as the ratio of the experimental মানে যেটো আমি observe কৰো experimentally observe কৰো value of the colligative property to the calculated value of the colligative property. Okay, so this definition is very important. Etu exam ot ahe definition to duta moi definition disu jikono eta dile hobo. It may be defined as the ratio of the experimental or observed value of the colligative property, তার experimental value divided by calculated value. Now calculated value, that is theoretical value গুলিও কয় ইয়াক, because calculated value মানে এইটো value আমি consider কৰিছো calculated value আমি association, we consider the solute molecules does not undergo any association or dissociation. Okay, so we can define I as the observed colligative properties. So observed elevation of boiling point hobo pare, depression of freezing point hobo pare, divided by calculated value of colligative property. Okay, again second definition is it may be defined as the ratio of the normal molecular masses to the observed molecular masses. Yat observed to ki hobo tolot denominator, yat observed to ki numerator ase no. If you remember that colligative property is inversely proportional to molar masses. molar masses already কৈছোঁ. So যিকেইটা colligative property পাইছোঁ, colligative property is inversely proportional to molar masses. So as it is inversely proportional to molar masses, so A to value observed value to denominator হ'ব আৰু calculated or normal value to numerator হ'ব. So in terms of molar mass, if we define Van der factor, then it is normal molecular mass divided by observed molecular mass. Okay. আমি বেলেগ ধৰণৰ ডিফাইন কৰিব পাৰোঁ. I is the total number of moles of the particles after association or dissociation divided by number of particles before association and dissociation. So total number of particles after association or dissociation divided by before dissociation. So association of কি হয়? Total number of moles of the particle due to association কি হয়? Decrease হয়. So if this numerator value decrease, then value of I is less than 1 in case of association. Okay, so you can see from here, so Van der factor I express the extent of association or dissociation of the solid particle in solution. So in case of association, this I value is less than 1. So association মানে কি আছিলে? I value is number of particle after association and dissociation divided by before. So association and number of particle decrease হয়, so I value automatically less than 1 হ'ব. So in dissociation কি হ'ব? Dissociation again I is equal to number of particle after dissociation, which is divided by before dissociation. After dissociation, number of particle increases, so I value is greater than 1 in case of dissociation. If I is 1, then no association, no dissociation. Okay, solid molecule, solid particle does not undergo any association or dissociation, then I is 1. So যেতিয়া আমি colligative property discuss কৰিছিলোঁ, normal colligative property, that is vapor pressure, relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, osmotic pressure, এই I term to আমি তাত নাই না, I term to, because we consider the solid particle, we choose the solid particle, এনেকৈ choose কৰিছোঁ that in that particular solvent, it does not undergo any association or dissociation. So solute particles বিলাক association dissociation হোৱা নাই, so I is equal to 1. But if it undergoes association and dissociation, to account for this abnormal molar mass, this Van der factor, that is association and dissociation কাৰণে এই term to Van der factor to introduce কৰা হ'ল. Okay, so if we dissolve 1 mole of sugar and 1 mole of salt, normal, that is sodium chloride, then their colligative properties will not be same, because sodium chloride will undergo dissociation. So as it undergoes dissociation, so number of particles will increase, but sucrose molecular association or dissociation নহ'ব. Okay, so next is modified form of colligative property. So এতিয়া যিকেইটা association or dissociation in case of abnormal molar masses, or for those solute which undergoes association or dissociation in a particular solvent, so abnormal molar mass আমি পাওঁ. So due to this abnormal molar mass, relative lowering of vapor pressure of solvent, so this is the relative lowering of vapor pressure is equal to Van der factor and NB by NA. This is actually, you can also write XB here. In the denominator part, NB is neglected, as we consider it as dilute solution really to consider. So relative lowering of vapor pressure is equal to I into NB by NA. Okay, elevation of boiling point, del TV is equal to, we know, KB by M. Now for abnormal molar mass, it is so you have to multiply it with Venter factor I. So depression of freezing point, similarly osmotic pressure. So গোটেই কেইটা colligative property লগত আমি just এইটা Venter factor to ইয়াত introduce কৰি দিছো. Okay, so this is the modified form of colligative properties. So let us try this one. 2 gram of benzoic acid. This is benzoic acid. Formula: dissolve in 25 gram of benzene shows a depression in freezing point equal to 1.62 Kelvin. Molar depression constant 4.9. So we have to calculate the percentage of association. So as we know, benzoic acid dissolve in benzene. So it will undergo what? It will undergo association. So given mass of the solute is given, it is 2 gram. Mass of the solvent, that is benzene, it is 25 gram. Then depression in freezing point delta TF 1.62 Kelvin. Molar depression constant for benzene KF, molar depression constant, it is given 4.9 Kelvin kg per mole. So now we can using this formula we can calculate the molar mass. So KF is given, WB given, WA given, delta TF given. So using this formula we can calculate out this abnormal molar mass, MB, experimental or observed molar mass. So putting the values and calculate, we'll get the molar mass of benzoic acid in benzene is 241.98. So this is the experimental or observed molecular mass of benzoic acid. So experimental or observed molar mass of benzoic acid 241.98 gram per mole. Now the calculated molar mass or normal molar mass, if we consider benzoic acid does not undergo any association or dissociation, so benzoic acid formula is this. How many carbon atoms? 7. So 7 into 12. How many hydrogen atoms? 6. 6 into 1. Oxygen atom 2. So 2 into 16. So it is 122. So association, due to association, molecular mass increases to 241.98. Okay, but actually it is 122. Now we can calculate out the I factor, Venter factor I. So Venter factor I is normal molecular mass divided by observed molecular mass. So value kiman? Value is 0.504. So less than 1 as association takes place. Okay. So Venter factor I palu. Etia ami ki koribo lage? Just we have to calculate degree of association. So if we consider alpha is the degree of association of benzoic acid, alpha, or you can consider X is the degree of association of benzoic acid, then benzoic acid, 2 molecules in benzene, dimerization takes place. 2 molecules, yat moi hydrogen bond show kora nai, just dimer. 2 molecules combine to give 1 molecule. Dimerization takes place. So if initially 1 mole is present, then product, it is 0. So after association, if alpha is the degree of association, then it is 1 minus alpha is alpha by 2. Okay, dimer or alpha by 2. From this we can calculate out I value again. So I value is what? Number of particles or number of moles after association or dissociation by total number of moles before association or dissociation. So I value, so total number of moles after association. So after association it is 1 minus alpha plus alpha by 2. So it will be 1 minus alpha by 2. So I value again A2 formula use kore we can calculate out the I value. So I is 1 minus alpha by 2. So again we know the value of I. Value of I yat put kore diu. It is 504. So value is alpha value is 0.992. So this is the value of alpha. So the percentage of association of dissociation is 92.2%. Okay, so as the value of alpha you can see it is 0.992. So degree of association or dissociation or percentage of association or dissociation is 99.2%. Okay, so this is association আমি discuss করলো. So এটা numerical dissociation occur. So let us consider 0.6 ml of acetic acid having density this is dissolved in 1 liter of water. So when we dissolve acetic acid in 1 liter of water, the depression in freezing point observed for the strength of acetic acid is 0.025 degree centigrade. Calculate the Van't factor and dissociation constant. So we have to calculate I and dissociation constant Ka for the acid. So first given volume of the solute, it is 0.6 ml. Volume density of the solute 1.06 gram per ml. Molar mass of the solute it is 60 molar mass. Volume of the solvent or water it is 1 liter, that is 1000 ml. Okay, again so from this value we can calculate out the number of moles of solute. So ইয়াৰ গুটি কেটা given value পৰা আমি molality calculate কৰিব পাৰো ন. So number of moles of solute, mass of the solute divided by molar mass of the solute. Now mass means mass of the solute is not given but volume and density is given. So mass of the solute is volume into density of the solute divided by molar mass. So volume is 0.6 ml. So volume is 0.6 ml. So it is 0.6 ml. Density is 1.06 and divided by molar mass of the solute. So if you calculate you will get number of moles is 0.016 mole. Okay. Next molality means molality again number of moles of solute divided by mass of the solvent in kg. Okay, so mass of the solvent is in kg. Mass of the solvent is not given, it is volume of the solvent, that is 1 liter. 1 liter diya ase na volume of the solvent, it is given volume of the solvent 1 liter is given. ठीक है. So you have to find out the mass of the solvent. How? Now mass of the solvent is equal to volume into density. So volume is given, it is 1000 ml and density we consider it as 1 gram per ml. So mass of the solvent is 1000 gram, that is 1 kg. Now putting the values, number of moles divided by volume of the mass of the solvent in kg. So it is 1 kg. So calculate korle molality is 0.0106 mole per kg. So molality value find out korle. Now using this relation again, delta TF is equal to KF into M. So KF value A value to দিয়া থাকিব হা, ইয়াত কোশ্চেনত দিয়া নাই বাট এক্সামত এইটো ভ্যালু প্রভাইড কৰা থাকিব KF value. So KF value this is for water molecule. So for water molar depression constant a value to দিয়া থাকিব, that is 1.86 Kelvin kg per mole. এই ভ্যালুটো প্রোভাইড করা থাকিব ইয়াত কোশ্চেনত দিয়া নাই ওকে সো ইনটু m সো ডেল্টা tf আমি ক্যালকুলেট কৰিলো ইট ইজ 0.0197 Kelvin. Okay, so this is our normal consider কৰিছো না because ইয়াত molar mass আমি কিমান consider কৰিছো acetic acid or 60 consider কৰিছো molar mass of acetic acid is 60 so আমি normal this delta tf value it is the normal or calculated value where we consider no association or dissociation takes place but delta tf value experimentally it is given it is 0.0205 okay so this is the experimental one so I vector factorize observe freezing point divided by calculated freezing point okay so it is 0.0205 Kelvin 0.0197 Kelvin so ইয়াত তোমালোকে সেন্টিগ্রেড দিয়া আছিল কোশ্চেনত মই ইয়াত কেলভিন লৈছো তোমালোকে সুধিব পাৰা কিয় লৈছো because this is the difference between the two temperature delta tf মানে difference between the two temperature so this difference is 0.205 degree centigrade দিয়া আছিল এতিয়া দুটা টেম্পারেচারে যদি আমি সেন্টিগ্রেডৰ পৰা কেলভিন লৈ কনভার্ট কৰি দিও so difference to same হ'ব this amount this much delta tf depression and freezing point that is difference between two temperature so দুটা temperature যদি আমি centigrade Kelvin লৈ কনভার্ট কৰি দিও তাৰ পিছত difference to same হ'ব so এই ভ্যালুটো আমি ইয়াত মই Kelvin লিখিছো okay so this is equal to 1.041 so this is the value of I so first question asile find out Venter factor so Venter factor I is this next one if alpha is the degree of dissociation of acetic acid then in water acetic acid dissociate to acetate ion and H positive ion now initially if we consider n mole then 0 0 and at equilibrium n 1 minus alpha n alpha n alpha that is here it is n minus n alpha so n common loy 1 minus alpha hol so total number I is equal to total number of particles after dissociation divided by number of particles before dissociation so after dissociation gote keta sum up korilo divided by n so it is 1 plus alpha now we know the value of I so value of I is 1.041 so alpha value is 0.041 okay thus the degree of dissociation of acetic acid is 0.041 now from this we can calculate out the concentration of acetic acid it is n 1 minus alpha so n number of moles alpha value is this again acetate ion it is n alpha number of moles is this one and alpha value is this similarly H positive or calculate korilo then just put the value in this formula Ka is equal to this put the values putting the values me and calculate it will get the Ka value is 1.86 into 10 to the power minus 5 okay thank you